Hello again. Sorry it's been so long for a video. Hopefully I can get these a little closer together. But this one, I wanted to follow up on my last demo. I had a few people reach out to me and say, hey, how do you connect all the Docker images or Docker containers to your database at the same time? And how do you push and pull data, and how does that all work? So I wanted to go over what I do right now. It may change in the future, but for what I'm doing right now, it seems to work for me. And as an example, I'm just going to put a few code snippets up from basically my run-of-the-mill passive subdomain worker that just hits a bunch of known tools that everyone uses, just to cover that base. So to start off here, as you can tell, again, this is in Go. If you want to learn more about what I'm doing or stuff like that, I'll make more videos on it and hopefully do some live streams on it as well. But if we look at the screen here, it's pretty simple what we're doing, starting with time, and I'm going to print a message and that kind of thing. These functions aren't really important. Basically, if you can't tell, you're going to take a domain from a Redis queue that we're going to talk about later. That will be my check domain. It's going to start passive recon on blank, and I'm adding 3 workers to a wait group. This is for asynchronous and concurrency in Go. So basically what I'm doing is I'm starting 3 Go functions in that wait group. That's why there's 3 there. So these 3 things will happen at the same time. So I'm basically testing subfinder with that domain, amass with that domain, and find domain with that domain. Just 3 very common domain tools that are out there right now. I'm just running them against that domain all in concurrency at the same time using Go. While they're waiting, I print the waiting message. So, hey, they've all been started. We're waiting for them to finish. It waits. Once they're done, that wait command will finish. It'll tell me how many domains I found from all 3 of the workers. Again, if you want me to go into the concurrency part of it and how I run tests at the same time, either look it up, because it's just Golang, and that's just the example I used. I'm not an amazing Golang programmer or anything. I just used some of the first examples that came up. But we can go over that if people have interest in that in later videos. But basically, it will tell you how many domains you found for each one. I also have some stuff there that will tell me how many domains I found for each tool as well. But pretty much all that's going to happen is then this stuff right here is how I insert it into the database. So I have a database library that I made, and there's a function in there called insert all subdomains. I remove any empty strings, I unique the list, and then this domains added list is going to be the domains that I want to add in. And then this check domain one here, this is basically putting in the check domain or the domain that I got from the queue that it did recon against, because in my database, I like to keep track of the seed domain that all of this information is coming from. That way, later down the line, I can query just for that seed domain. I can say, okay, this seed domain of tesla.com gave me how many subdomains, how many resolved subdomains, web ports, all this kind of stuff, because everything links back to the seed name, or seed domain, root domain, whatever you want to call it. And then it's very easy to connect those root domains to the program. So the program that is Tesla, I have a little spot for that in another table in my database that says, okay, this is Tesla, it's on BugCrowd, and these are the URLs that are part of the program. So now, since everything's linked via seed domain in my database, I can say, okay, Tesla, give me everything. Or some of these other bigger programs that have maybe 8 or 9 seed domains in them, I can be like, okay, for this program, give me everything. And it just adds that extra step of first pulling the 9 seed domains and then looking for everything connected to those. So that's why that's there. I'll talk about this function in a minute and other ones. I made a little Discord library so I could send myself messages for how many new domains I found, or if there's no new domains found this run, and some kind of a runtime. So I can keep track if runtimes get a little weird. That's basically my way of saying hey, maybe look at your automation. If all of a sudden it's running 4 times as long, or all of a sudden it's finishing every 10 seconds instead of what it normally runs, the runtime is normally pretty similar for me when it's running through one domain at a time. So if the one domain runtime is all of a sudden very quick or very long, that's probably a good reason for me to go check it out. So that's what that's there for. So again, this is something super basic. Again, just running 3 passive tools that everyone knows. It's really nothing as far as the actual tools used to find the domains. Everyone should know about subfinder, amass, find domain. They're already out there. You might as well use them. You can build your own stuff on the side, just like I did. I have some other workers that do some of my own stuff on the side. As you can see on the side, I have a bunch of workers here that I've been working on, and I have even more that just aren't in the workspace right now. Brute forcing and permutations and all this other kind of stuff, zone walking, whatever it may be. But this is something super easy to start with. That's just like a passive run 3 tools on a domain, pull me the results using Golang. And this is kind of my database library. So how I connect to it is this database library will come with the subdomain worker, right? So this subdomain worker, if you can see, has everything that it will need to deploy with it. It has the Docker file, which it'll deploy. These config files don't really go with it, right? Like obviously those are my personal ones. They have my keys in them and whatever, right? And then this find domain zip file will be, unzipped during the runtime to basically add the find domain binary. So I can just add the binary right to the Docker file I'm making. But anyway, to the database, this is the database library for this subdomain worker. And all my workers might have a little different database workers, but a lot of them are pretty similar. So through the time that I've been building it, there's been a lot of things that I've needed. Querying subdomains, querying seed domains, and inserting into the all subdomains list, which is where I insert my beginning list of subdomains. And all of them start the exact same using Golang. So they declare a domain object, or they declare a subdomain object, which are these up here, which is going to be the data that I get back when I'm querying a database. If I'm doing inserts, then I obviously am not pulling data out. They all start the same way with this PSQL info line. And if you'll notice, I'm getting the host, port, user, password, DB name, all that stuff is all an environment variable. Because when you go into DigitalOcean, which I will show in a second, and create your database, it gives you all of these credentials. And then when you go in to create an app in the app platform, or anytime you spawn a Docker image anywhere, there's always the option to add environment variables to that container. So it's super easy to just add in these environment variables to every container you make, and then every container is able to run this code and connect to the database. I think the DigitalOcean one, the base one, you can connect you can have like 100 concurrent connections, I think, at one time or something like that. So that means with the base version of the database, the most I could have is like 100 workers trying to connect to it at the exact same time. Using the library and using DigitalOcean's managed database really does all of the work for me as far as making sure there's not like double overwrites or double pulls or anything like that. As far as I'm aware, I haven't ran into that issue yet, because again, this is what I'm doing so far. I may run into issues in the future, if so I'll update it, but for now this works really well for me. So they all start the same. As I put in this PSQL info, I try and open the database, which isn't getting any data out yet, right? It's just opening it and it's pinging the database. So it opens and pings and makes sure, okay, your connection works. Prints out that you've established a connection, great. And then you can actually do your inserts, your queries, your everything else, right? So in this one, for selecting subdomains, this would be my query, is I'm just selecting the subdomain, when it was the subdomain tested, and when it was last tested, right? And it will pull me rows and an error if there is. If the error is something, then print the error and keep going and do that. Otherwise, for every row that's there, I'm starting with that subdomain object now, which again is this object up here. So every subdomain object will have a subdomain, tested, and last tested in it. I already made that struct. So I'm declaring one. And then for each row, I'm just scanning it in. I'm just scanning it in. And if there's an error, tell me there's an error. And then all I'm doing is appending it to a list of those sub-objects. That's all I'm doing. And then I just return the list. So that was how I would query for all my subdomains. And again, every worker, if I have 8 subdomain workers going at one time, great, because they can all connect on their own. They can all do things on their own. They're all their own connection. As long as I don't have a million workers trying to connect, we're fine. And every environment will have its own environment variables. So there's no like hard-coded variables anywhere in the code. There's no hard-coded anything like that, right? It's all good. So the next step, if you want to, again, querying seed domains, same thing, just like a different table, right? So all the connection stuff works the same, and then the query is different. Inserting, on the other hand, same thing at the beginning, all the way up to establishing connections. Nothing changed, right? But then the query is for this list of domains that I passed in. I'm going through each of those domains and I'm trying to insert it into the all subdomains table as is with these values. And then this is me executing the command with the SQL statement. And then these $signs are how you do parameterized statements in Go. So for $sign number 1, I have domain, and $sign number 2, I have seed domain. go through. If the error isn't equal to something, I first check if the error, so this line right here is saying if error isn't none, like if there is an error, go into here. But instead of just stopping the code because there was an error, the first thing I do is check if the error contains duplicate, meaning like, hey, the subdomain you just tried to add is a duplicate, which could happen. So instead, I print the message because I like going through logs and debugging and stuff if I ever have an error. But this is telling me, okay, this subdomain is actually already in the database. You're not going to add it again. And then it just ends. It doesn't panic and stop the code. It just continues running. But if the error isn't anything, then I know there's no regular errors and there's no duplicate errors. So that domain was actually added to the database, wasn't in there before, wasn't in that table. So I added to a domains added list, just a list of strings that are going to be domains. And at the end, I return the domains added. So again, this insert all subdomains takes a string of domains, attempts to add them to the table. If it's a duplicate, it doesn't add them. If it's not a duplicate, it will add it. And then it returns a string of all the domains that I just added that weren't duplicates. So when you go back and look at that function running here, right, I removed all empty strings and unique the list. So this whole thing is telling me that there's going to pass into the function the list of domains added, uniqued and removed empty strings, and then the seed domain. And from it, I'm going to get a final domains added. And right here, where you see here, if the length of that list is greater than 0, that means there were domains that I did add to the database. There were new ones. So in that case, how many were there? And that's how many new domains were found that run. And here I commented out because I used to send a Discord message that actually printed the new domains. The only problem is I have to fix something right now where when I onboard a new domain, obviously there may be a bunch of new subdomains coming in on the first run. And it actually got so big, it would crash the Discord worker sometimes if you found like 1 million domains that it would try and all send to Discord. But yeah, so I'll have to fix that in the future. But otherwise, it will send a message saying no new domains found. Every worker can do this. They can all do it concurrently because they're all grabbing from this Redis worker, right? They're all just grabbing domain after domain after domain. If you don't understand what I'm talking about by grabbing it from the Redis worker, go back, watch some of my earlier Docker automation videos where I go over the architecture of what I'm talking about, of each worker grabbing a domain out of the Redis queue. So each worker is working on its own domain. And with this, I can have 5 workers. That means I can handle 5 domains at a time, and they're all scanning themselves. They're all going into the database themselves because each worker has those environment variables from up here to connect to the database and do what needs to be done. Now, really quick before I get done, because the video is already going pretty long, over here you can see I only have 1 worker deployed right now because I'm still testing stuff and bringing stuff up and down. I haven't deployed it as a production like tool yet with all my workers because I want to make sure they're all work right before I just really go all in. And as you can see, I have a Redis queue here, and I also have a Postgres database. And these are the databases that I use to do what I was just showing you, right? It's pulling from this Redis queue, and it's storing data in this Postgres database. I'm not going to click on it because there's credentials and stuff in there, all that kind of stuff, but I'll show you what I'm talking about, where if you create a database, you go to create in DigitalOcean, database, and then you can pick. This is all I did. So I'm using the New York and the US. But you can pick whatever database you want. MySQL, Postgres, Mongo, and Redis are the ones that they manage. You can choose versions for some of them. And again, it looks like for most of these managed solutions, so there you go. There's a good answer. So for Postgres, it's actually a connection limit of 22. So I could have 22 workers connected actively using the database at the same time before I hit that connection limit. So that's a perfect answer for that. And then there's Redis queue here. This is the Redis queue that I pull from to use my queues. And again, you can use pro plans and up it and do all that kind of stuff as you scale out. And when you create this database, it will give you credentials, the host, passwords, the default database table that's all in there and all that kind of stuff. And you can change that as you want to and all that kind of stuff. And it's very easy to set up. And then again, you just will take that out of there and store it as environment variables. And then when you deploy something, for instance, let's just say I want to redeploy an app. So I want to go to the apps platform. Let's just go here. And I want to create a new app. And let's say I wanted to redeploy that subdomain worker. So I want to redeploy the subdomain worker. Here we go. I go here from branch main. Sure, we'll take off auto deploy. You can leave it if you want. We've gone through this kind of stuff before in the last demo, if you remember. If you haven't watched it, I'd recommend you watch it. I won't set up any of this, but right here you see, boom. Option number 2, environment variables. And I mean, I put 2 work. Okay, so let's get rid of 1 worker here just to make it easier. So there's 1 worker, you're deploying 1 worker at a time. Here we go. Environment variables, I can set global environment variables. That's for everyone, so all the workers in this environment. Or I can edit them just for the subdomain worker. And if I do edit, you can either put key value pairs like DB name and then put it over here, Or if you're used to, just editing like a .bashrc file or something, you can use the bulk editor and just do, DB name equals just like you would in a bash.r or .bashrc file. And you can just bulk edit, click save, and it'll save as many lines as you have there. Just like it is. You can encrypt them if you want, all that kind of stuff, whatever you want to do. But then these environment variables are there at build time and runtime. So if you need environment variables at build time, great, still has them. If you need them at runtime, great, has them. So now any worker that I deployed doing that would have those environment variables into it and would be able to connect to the Redis queue and my Postgres database, and all the workers are doing their own thing with their own database connections. So I think that's all I really have for this one. Again, I love when you guys ask me questions and basically give me ideas for a lot of these videos. I love talking through what I'm doing. Again, it's obviously a not finished product, but I'd love to hear your thoughts on it. I'm pretty open about what's going on here. If you want to see more, let me know. Other than that, I hope you guys learned something. Hit me up on Twitter, Discord, all that kind of stuff. Other than that, I'll see you in the next one. Peace.